Okay, guys, good morning or evening, depending on when you're watching this, or afternoon, I guess I should say. Our next unit is going to be all about what we call solving a triangle. And the key to solving a triangle is to be able to find all of the missing angles and missing sides. Now, we're going to start with triangles that we are a little bit more familiar with. We're going to start with right triangles and kind of think about what we know from Trig that might help us with that. A lot of this is going to be based on drawing good pictures. So we're going to draw a triangle, we're going to draw a triangle ABC where angle C is a 90-degree angle. So if I kind of start over here, I'm going to mark angle C as my 90 degrees. Angle A is 40 degrees, so one of these can be A. And then we know that side C is 17 feet. Well, we're going to come back to that. This angle has to be B. One thing that we know is that the three angles of a triangle add up to 180, which means that this missing angle has to be 50 degrees. Okay, now the 17 feet. When we're labeling triangles, just to be consistent, we will always use a lowercase letter to label a side, and it will always be across from the angle with the same letter. So we use capital letters for angles, we use lowercase letters for sides, but they will be across from each other. So side C is the side across from that angle C. That's my 17 feet. Now, my task was to find all the missing sides and angles. Immediately, I found the measure of angle B to be 50 degrees because the angles add up to 180 in a triangle. Now, finding the missing sides. This is where we need to remember back in geometry when you guys learned SOHCAHTOA. And as a reminder, if you don't remember SOHCAHTOA, this just represents that the sine of the angle is the opposite over the hypotenuse. The cosine of the angle is the adjacent over hypotenuse, and the tangent of the angle is the opposite over adjacent. So for each problem, we need to figure out which side we want to work with. For example, let's say I wanted to find this side first, okay? Based on the side that I'm looking for, I just need to pick one of the acute angles. Doesn't matter which one you pick. Maybe I'll pick this 50 degrees, okay? And you want to pick one of the sides that you actually know. Okay, so I'm going to use the 17 feet because I know it. Based on the angle that I've picked, I'm using my 50-degree angle. The side that I'm looking for is opposite that angle, and I'm using the side that was given, which is the hypotenuse of the triangle. Based on that relationship, I know I need to be using my sine ratio to be able to solve this. Okay, now according to the equation here, we're going to do sine of the angle. I'm using that 50-degree angle. My opposite side is my unknown. I'm going to call that x. And my hypotenuse was given. That was 17. Now, solving this equation, you can do a number of things. I always like to write a proportion and then cross multiply. So to solve for x, I'm just going to multiply the sine of 50 degrees times 17. Okay, in your calculator, just double check that your calculator is in degree mode, and then you can just enter that in. Sine of 50 times 17 gives me a side of about 13.02. Okay, so the one side is about 13.02. Now, because that side is rounded, we really do not want to use that side to find anything new because it's not an exact answer, it was an estimate. So we're going to kind of start over to find my next missing side. Okay, this time I'm looking for this side, and I can choose. I can either pick the same angle or I can use a different angle. Let's say I pick the same angle, the 50 degrees, and I am still going to use the side that I was given. So I'm still going to use the 17 feet. Now, using this piece of information, the side that I'm looking for is actually adjacent to my 50 degrees, and I'm using my hypotenuse. So this time I'm using my cosine ratio, okay? Setting up an equation. The cosine, again, the angle I'm working with is 50 degrees. The adjacent is the side I'm looking for. I'm going to call it y. And the hypotenuse is the side I'm given, so 17. And again, we're solving the equation. I'm going to divide by, I'm going to write a proportion. If I cross multiply to solve for y, I'm just multiplying my cosine of 50 times 17 to get my y value. And again, just as long as your calculator is already in the right mode, you can enter that in. We get a y value of about 10.93. Now, one thing I always like to look at, or just to point out, just a little geometry tidbit that might help you when you're checking work. Remember that the hypotenuse should always be the longest side. So you do want to make sure that your other two sides are smaller than the 17, which they are. I also like to point out that the smallest side will be across from the smallest angle. So as long as if 40 degrees is the smallest angle, then the side across from it should be the smallest side, which it is. So it's just a quick thing I do to check to make sure I haven't miscalculated anything. Okay, there's one example, guys, of how we can use trig to be able to find any of our missing sides if we know at least one side and then some of the angles. My second example is going to be finding some missing angles. Now on this one, we know that angle A is 90, so I'm going to call this one my 90 degrees. And then the other two angles, we don't know which is which. So call one of them B, one of them C. It does not matter. What does matter is that the side across from B is going to be my 21. So that's going to be this side. And the side across from A is going to be 29. That's going to be this side here. Okay, and of course our job is to find all the missing information. Well, I'm actually going to start by finding the side across from angle C. We're going to call that side C. And because I already know two of the sides, all I really need to do here is Pythagorean theorem. So 21 squared plus C squared equals 29 squared. 21 squared is 441 plus C squared. 29 squared is 841. If I subtract the 441, I'm going to get 400, which means C is 20. Now, some of you may have recognized this as a Pythagorean triple, but it's not a common one, so a lot of people don't recognize that. Okay, now to find the missing angles. We need to pick which angle you want to find. It does not matter. I'm going to find angle B. Okay, then you need to pick two of the sides that you want to use. Again, either side, it does not matter, but don't use rounded values. So for example, if I did not get a perfect number, like number 20, if I did not get like a perfect square, don't use that one. Okay, I'm going to use the two sides that were given. I'm going to use the 21 and the 29 to help me find angle B. Now, the 21 is opposite angle B, and the 29 is the hypotenuse. So that tells me to use my sine ratio. So if I do the sine of angle B, I'm going to write the ratio 21 over 29. Okay, now remember, in this case, I'm actually solving for the angle. So to solve for the angle, I need to undo sine, and I can undo sine by doing the inverse of sine. And then there is my ratio. Okay, this really isn't any different than what you guys did in the last unit, just you were given decimals instead of fractions. So again, in your calculator, we're going to do inverse sine, 21 divided by 29, and we're going to get an angle of about 46.397. I'm just going to round that to 46.4. So angle B is 46.4 degrees. Now, the nice thing about this one is with angles, you know that the three angles of a triangle have to add up to 180. You know that angle A is already 90, so these two angles have to add up to 90. So if you just subtract 90 minus that previous angle, you can actually get your missing angle a little bit faster. This one is just 43.6 degrees. So today we're going to be working with problems like these, where we are going to be using one of our trig functions to be able to solve for a side or an angle, depending on which it is that we're looking for. But a lot of the ones we're going to do here today are going to be more applications, okay? So I want to start with just a quick little, actually I might skip this one and kind of come back to that. Let's go to angle of elevation and depression, because you're going to need to work with this type of description in some of our problems here. Just to kind of reiterate what this means. An angle of elevation means that we are starting at, think of it as like starting at a low point. So let's say you're a person standing down here, Okay, always start with what is your horizontal. Okay, so from whatever point you're at, draw your horizontal. Elevation means that you're looking up from that horizontal to something up here. This is called an angle of elevation. Now, if I was starting at a high point, let's say I was actually starting, I was a person on the plane, and always start by looking out horizontally and then looking down. This angle is what we call my angle of depression because I'm looking down from the horizontal, angle of depression. Okay, you can see the same thing in the next picture, right? If you're standing at the top of the building, you look out horizontally, and then from there you look down. That's your angle of depression. Or if you're the person that's standing on the ground, oops, sorry, I was going to switch colors. If you're the person standing on the ground, there's your horizontal. You look up. That's your angle of elevation. Now, one thing I like to point out is that the angle of elevation will equal the angle of depression because if you think way back to geometry, your horizontal lines are parallel. Okay, we use these little symbols for parallel. And when we have parallel lines, these angles are what we call alternate interior angles. And alternate interior angles are always congruent as long as there are parallel lines. So that's a nice little thing that allows us to kind of work with multiple triangles. If you kind of look at these two pictures, I could draw a little triangle on this side, I could draw a triangle on this side, I got a couple of different triangles that I could work with. Okay, so let's look at a couple examples where we apply some of those earlier skills, but with where we have to draw our own picture. Okay, we're starting with a 75-foot flagpole. So if I draw a flagpole, okay, there's my flag. I know that it is 75 feet tall, so I'll label that. It casts a shadow of 43 feet. Now, obviously, guys, a shadow is on the ground, so I'm going to label my shadow on the ground. We want to find the angle of elevation. Now, the fact that I'm asking for an angle of elevation means that I must be on the ground looking up. And we want to start at the tip of the shadow. So we're going to start right here, okay, and we're going to look up from there. Now, it says to the sun. Okay, that's just making sure you understand, class, that the only way there would be a shadow on the ground is if there was a sun behind the flagpole over here shining down on the flagpole. And when that sun shines down, it's going to create this, this line. Okay, so what we're looking at here is, again, a right triangle, assuming the flagpole is standing straight up. Okay, so we do make a little assumption here that this is not the Leaning Tower of Pisa and that it is standing straight up. Our job is to find this angle of elevation. I'm going to call that theta. Now, using what we just learned, we can look at the two sides that we're given, this one and this one. Okay, the side across from that angle is the opposite. The side next to it is the adjacent, and the trig function that compares opposite and adjacent is tangent. So I'm going to use this equation to be able to find my missing angle. Since I don't know the angle, that's going to stay as my variable. My opposite is 75, my adjacent is 43. To solve for the angle itself, I will do the inverse, and I will type that in. So the inverse tangent of 75 over 43 is an angle of about 60.17 degrees. All right, oops, it says to the nearest degree, so we're going to say 60 degrees to be more exact, or not more exact, but to be to follow the directions. So it's these kinds of problems, guys, where we're actually applying those trig ratios. Okay, let's look at another one. A man climbs 213 meters up the side of the pyramid. So he's going up the side of the pyramid. He goes 213 meters up the side of the pyramid. Okay, we want to find the angle of depression. So first of all, that means he's at the top and he's looking down. Now, I said whenever you do an angle of depression, start by drawing a horizontal, and he's looking down from that horizontal. That's the angle that I'm looking for right here. Okay, it's technically like outside this pyramid if you really look at it. We want to know, the angle of depression to his starting point is 52.6. So actually, they're giving us the angle of depression here. We know that this angle is 52.6 degrees. We want to know how high off the ground is he, okay? Well, our guy's standing right here, right? His height is going to go straight down. The one thing I like to remind you guys is you can draw that height anywhere. You can draw the height right where I drew it, or you could draw the height right over here. It doesn't matter. It's the same height, okay? Somewhere in this picture, you just need to pick a triangle. I'm going to focus on, and again, it doesn't matter, but I'm going to focus on this triangle right here, okay? This is my right angle. I know this side, and I know the 52.6 degree angle. So starting with this angle, okay, I need to find the height. Okay, this is the side I'm looking for, and you'll notice that this side is opposite the angle. I'm also going to use the side I was given, which is the hypotenuse of the triangle. So the trig function that compares opposite and hypotenuse is my sine function. So this is the equation I'm going to be setting up. This time I know my sine ratio. I know my angle. My angle is actually 52.6 degrees. The opposite side is what I'm looking for, and I have been given the hypotenuse of 213. So going back to one of those earlier problems, I can draw a proportion. To solve for h, I'm just multiplying the sine of 52.6 degrees times 213. And again, if we throw that in the calculator, times 213, we get a height of about 169.21. And it does say hundredth, and the units are meters, so I'm going to end that with meters. Okay? Okay, one last example, because some of these diagrams can get a little intense, and you really, really, guys, have to draw this out, okay? So we've got one more. There's a cell phone tower, 150 feet tall, on top of a mountain that is 1,200 feet above sea level. So I'm going to start with drawing a mountain, and the height of the mountain is 1,200 feet above sea level. On the top of this mountain is a cell phone tower, and the tower itself is 150 feet. Okay, now we want to know the angle of depression. So again, angle of depression means I must be starting at the top of the tower. So I'm starting up here and I'm looking down. Start with drawing your horizontal, and I'm looking down from that horizontal. Okay, now I'm looking at a cell phone user who is 5 horizontal miles away. So basically, this horizontal distance that I'm going out, this is a horizontal distance of 5 miles. Now again, I can draw that horizontal distance anywhere. I can draw it there, I can draw it down at the bottom. It doesn't matter where I draw that horizontal distance. Okay, the cell phone user is 5 miles away, but he's also 400 feet above sea level. So he's not standing down here on the ground. He's up here about 400 feet. Okay, what we're trying to figure out is the angle of depression from the top of the tower to that guy right there. Now again, find a triangle. Draw a triangle in this picture. I'm going to draw the triangle up here. Okay, I'm going to draw the triangle at the top. I'm going to look at this triangle right here. And again, you can use a lot of triangles in here. This is just the one I'm looking at. Okay, the angle I'm looking for is this angle, the angle of depression here. Okay, in order to find that angle, I need a couple of sides. Now, one thing to point out is the units. My horizontal distance is in miles, but everything else is in feet. So the first thing I'm going to do is convert that 5 miles into feet. Remember that there are 5,280 feet in a mile. So if I multiply 5,280 times 5, this is 26,400 feet. Okay, the next distance that I need is this distance. And again, it just depends on which triangle you're using. I need this distance. Okay, well, on the other side of the triangle, I have a total height, if you include the mountain plus the telephone pole, this is a total height of 350 feet. Okay, well, that's going to be the same on this side, right? 350 feet. But I'm subtracting the 400 feet because he's not standing on the ground. So if I subtract the 400 from that, this is actually 950 feet. Now, looking at this triangle, I'm solving for the angle of depression over here. The side across from it, this is my opposite. The side next to it, this is my adjacent. Okay, keep in mind, guys, wherever your right angle is, the side across is the hypotenuse. I don't know anything about the hypotenuse, so I'm not using that one. Okay, I'm using opposite and adjacent. That means I'm using tangent to be able to solve this. Tangent equals opposite over adjacent. Okay, I am solving for the angle, so that's my variable, but I can plug in the opposite side of 950 and the adjacent side of 26,400. And to find my angle, I will do the inverse tangent of that ratio. So second tangent of, 950 divided by 26,400. And I get an angle of about 2.06 degrees. So a very small angle there as we're kind of looking down at that angle of depression. So tonight, you guys are going to work on some problems where you're working with using these trig functions, using right triangles. So you've got to find a right triangle in your picture. And again, label the information carefully.